Hi, I'm Jane, an AI agent trained by Orange Brackets, and I'll be your instructor for this tutorial. Today we're answering a fun question. How does ChatGPT speak many languages and even write code with one single model? We'll walk through the big ideas, then run a small demo so you can see how the pieces fit together. Ready? Let's get started. This lesson is adapted from My Data Guest, and there's a companion video on orangebrackets.com. Here's our roadmap. First, multilingual training data, then emergent behavior. What models start doing at large scale? Next, the quiet workhorse, Subword tokenization. And finally, we'll peek at how tokenization actually breaks a sentence into pieces. By the end, you'll know the practical reason ChatGPT can generalize across dozens of languages. Let's start with the training data, the raw text the model reads during training. Even if most of the data is English, there's still a lot of non-English mixed in. At the scale of modern models, a small percent still means billions of examples. So what does that buy us? Let's unpack it. ChatGPT can communicate in many languages without a separate submodel for each one. One brain, many languages. Why? Patterns transfer. If a model learns grammar, word order, and common structures in one language, it can reuse those ideas in others, especially after seeing enough examples. Performance is best in high-resource languages like English, Spanish, or Chinese. But thanks to scale, it can still do surprisingly well in rarer languages. Think of it like music. If you're great at piano, picking up guitar is faster. Your rhythm sense carries over. If this still feels a bit abstract, no worries, the demo will make it concrete. Now let's connect this to what happens when models and datasets get really large. Emergent behavior shows up when models get big and data gets huge. They're trained to predict the next word. That's it. But at scale, they start to translate, summarize, reason step by step, and follow instructions. In simple terms, the model builds a rich internal map of language. That map lets it connect ideas across tasks and across languages. We don't fully understand every detail yet, but we do know that scale plus structure leads to these new capabilities. Next up, the quiet hero of multilingual AI, Subword tokenization. Models don't read full words or single characters. They read chunks called subwords. A popular method is BPE, byte pair encoding. Here's the intuition. Imagine words built from Lego bricks. Common bricks get reused everywhere. Prefixes, roots, endings, emojis, even bits of code. Rare words are split into a few bricks the model already knows. How does BPE learn these bricks? It starts with characters, then repeatedly merges the most frequent pairs. Over time, it forms a compact vocabulary that works across languages. OpenAI's tokenizer goes even deeper. It can operate at the byte level. That means it handles many scripts and symbols without getting stuck. Why this matters? Subwords make the vocabulary efficient, flexible, and language agnostic. They let one model read Italian, Arabic, Hindi, and Python, all with the same building blocks. Let's see tokenization in action with a quick Python demo. We'll pass in a couple of sentences and watch how the tokenizer splits them into subwords. Pay attention to repeating chunks across words. That's the model's reusable Lego set. Don't worry if this feels tricky at first. We'll walk through it step by step. First, we'll import TikToken for tokenization and subprocess plus sys so we can install things on the fly if needed. All right, with that sorted, let's load the tokenizer we want to experiment with. We'll grab the CL100K base encoding and store it in a variable called enc. This is a common tokenizer used by modern models. Time to add a couple of example sentences so we can see how they break into tokens. We'll start a list named sentences and add our first Italian phrase, great for testing non-English tokenization. Now we'll add a second sentence also in Italian to give the tokenizer a different mix of words. Close the list. 2 sentences are enough to keep the demo clear. Now let's loop through each sentence and see what the tokenizer does. For each sentence, we'll encode it into token IDs, decode each ID back to its text piece, and then print 4 things: the original sentence, the token pieces, the raw IDs, and the total number of tokens. No code? No problem. You can try this visually with the TikTokenizer app. Paste any sentence, choose KL100K base, and see the token breakdown. Compare a few languages. Notice how common chunks repeat. Also check the total token count. That's useful for estimating cost and context length in real projects. All right, let's bring it home. So, why can ChatGPT handle so many languages? Three forces work together. 1. A massive training set that includes non-English data. 2. Emergent behavior that appears when models become large and well-trained. And 3. Subword tokenization, which lets one vocabulary cover many languages and scripts. In practice, tokenization is the most concrete day-to-day reason. Those shared subword pieces make multilingual generalization efficient and robust. Your takeaways. When building multilingual apps, pick the right tokenizer, keep an eye on token counts, and expect some transfer across languages. But test carefully for low resource cases. Thanks for learning with me. I'm Jane from Orange Brackets. See you in the next tutorial.